Right, new section today. We're going to find out how to find the area between two curves. It's actually a new chapter. We're starting chapter 6. So chapter 6 is, hey, we know how to find integrals. What can you do with them? Well, here's one. You can find what's called the area between two curves. So I want you to imagine the curve, this one at the top called y equals f of x. You know, it could be x cubed plus x. And you got this green one below it, and that's called y equals g of x. And we want to find this area between it. And the area between these two curves is given by this integral. Now, when you look at it, it's actually quite a simple formula. Don't you take the formula for the top and subtract the bottom? Right. Now, a couple of things about this area. Do you know that when you do net area, just a single integral, can't the answer be positive, 0, and negative? Depends on what the curve's doing, right? If the curve's all above the x-axis, it's positive. If your curve is all below the x-axis, it's negative. And do you know if you get one of those like sine curves, half above and half below, you could even get a net area of 0. So when you do a single integral, positive, negative, and 0 can happen. But this is a physical area, right? A real life area. These guys are always positive. They're never 0 and they're never negative. The way they are created, it always ends up with a positive answer if you do it properly. So if you're doing one of your questions in your homework and you do the thing and you set it up and you suddenly realize that the answer you got is negative 10, then you've made a mistake, essentially, right? If it's 10, you're probably okay, but if it's negative 10, something's not right, fix it. Okay, now we're going to return and do some questions on this, but before we do that, I want to show you a piece of software called Desmos, because you're going to use it a lot in this section. Let me see if I can find it. Never find things on a line for them. Here we go. Okay, maybe make this a little bit bigger. Okay, so I'm going to move over now and you're going to see basically what you should be seeing when you go into our Canvas shell, right? And there is Desmos. Have any of you used Desmos before? Because that's going to make your life a lot easier if you have. Right. So essentially what Desmos does is it allows you to draw graphs. It's a bit better than your TI-84. Your TI-84 is a tiny little picture and you don't get the benefit of color or the ability to easily change scales and so on. So let's suppose that I type in y equals x squared plus, I got in capitals for some reason. Y equals x squared minus, say, 2x. I should watch what the heck I'm doing. There we go, third time lucky. Do you see it draws it over here? Let's put in another thing. Let's do y equals, let's just do y equals x. Now, red, y equals x squared. Blue, y equals x. Isn't that a lot easier to see, quite clean, quite quick? Now, you might want to have to change some things. If you have a mouse, you can move your little mouse pointer in, you can move your little mouse pointer out, the little wheel on it. If you don't have that feature, if you hit this, you can choose what x values you want. So let's suppose I only want to look at x values from, say, -1 and finish at x values at, say, I don't know, 5. And maybe I want to do y values from, I don't know, -2 and finish it, I don't know, finish at 6. Right. So You see, you can move things around. You can kick if you hold your mouse pointer on it, the left mouse pointer, you can even drag it around a little bit. So can you see you've got a lot of versatility on what you can sketch and how you can adjust size. Now you have another couple of cool features. If you take your mouse pointer and you hover above a point, come on, there we go, there. Do you see it will actually tell me the coordinates of that point? Let's suppose I want this one, which is quite clearly the origin, right? I want this one. You see, you can actually find quite a few guys. If I clicked on that, not very helpful. But if I clicked on that and keep my mouse pointer on it, you see I can see the coordinates. So you can even do things like find where two curves intersect by just putting your mouse pointer on it, right, and giving a quick click like this, or just put it over the top, and you can tell that they intersect at x equals 3, for instance. Now those drawing sketches, looking at pictures is going to be very helpful in area between two curves. Some of the questions that you get actually give you 4 pictures and you have to pick the right one. So you'd go here, put it in Desmos, look at the Desmos picture, then look at your homework and say, it's the same as number 3. And that way you would pick it, right? So that's part of the question. Now there's another thing that this does that your TA I-84 doesn't do. Do you notice that I've now done an x equals a function of y curve? So basically it's saying the x coordinate is given in terms of combinations of what the y coordinate would be. If I hit enter, I could put in that. Now the reason that you're going to do this is that we're showing you how to find the area between two curves. We don't always find them in terms of x, x squared and 2x. We might do it in terms of, y squared and 5y, right, going this way. So sometimes you find the area kind of vertically, and sometimes you're finding area between two curves horizontally. When it's the area between two curves and it's a vertical one, it's going to be x squared, y equals x squared and y equals 2x plus 1. But when you go the other way, it's going to be guys like this. So the area between these two curves would be this little blob here on the left that my mouse is kind of traveling around. And just like before, if you go there, can you see its coordinates are 3, 3? So I can tell where that intersects. We cool with that? Cool. So have a little bit of fun. I'm sure there are videos in using Desmos online as well. So if you're not sure of, what that little toolbar can do, you can see here it's got some pretty minimal directions, about what you can do, and that's fine. There's some here for people who have visual impairment as well, which you would use in that case. Now, see that little guy here that I clicked? Keyboard, right, disappear, back. If I didn't want to do that funny, the little caret thing, and I wanted to do y cubed, for instance, there's my y, you got it? And then I could do various powers, like that one, for instance. So see if I can do that one. Click on it. Let's do y equals x cubed. So allows you to do powers without remembering the special key. I think that's all the obvious stuff. Is there anything else about Desmos, those who've used it, that you would might want to share with us right now?
Button. Click on the function.
Right, let me get this. Yeah, let's get this right. Click on this guy.
On the keyboard.
Okay.
And then you go functions all the way to the right.
Okay. Oh,
So
that's how you get all the weird inverse signs and things. Yes. Actually, I think when we do volumes, especially, we'll be using an inverse one, but certainly the sine and cosines are going to be helpful. Thank you. Okay, so just go. It's free. Make a link on your link and get used to it. Right, I'm going to move this guy out the way, and we're now done in space. I am so good at not swearing. It amazes me how I have such self-control. It's not that I don't swear, but I keep swearing for special occasions, like banging your toe on the door, falling over, my football team getting beat, politicians lying at me and thinking I'm dumb enough to believe them. Like that. Now, let's go back. And we're ready. So, if you want the area between a curve, it's the integral from x equals a, the start, to x equals b, the finish. The top function is f of x, and the bottom function is g of x. So when you're doing a function like this, I very often put in a little rectangle. And it's just a way, top, bottom, F, G, right? Most people can just look at it. They don't need a rectangle, but it's there. So let's suppose that I do question 1, or at least one like question 1, and show you what it looks like. We are being asked to find the area between y equals 12 minus x squared and y equals x squared take away 6. Okay, so hold that thought. I'm now going to have to go to Desmos and do the first piece of the puzzle, which is sketch it. And that's going to give me a lot of the information that I need. So I'm going to kick these two guys out. And the first one, y equals 12 take away x squared. That's that one. And the other one's y equals x squared take away 6. And clearly that's not good. So if I just use my mouse pointer, can you see that I can scroll back? Oh, you can't see it, sorry. Thought you could, but I was wrong. There we go. Right, so you see it now?
Yeah.
Right, so y is 12 minus x squared, y is x squared minus thingy. This is what it looked like when I first put it in, because my window just wasn't a good window. So I have a little wheel on my mouse pointer, so if I scroll back on that wheel, it just basically like pans out. All right, I think I know what the heck's going on here, right? So the area between the two curves is this piece here that looks a bit like melon head, which is here. Right, a big melon. And I need to know where that starts and where that finishes. So I need to know that one. Do you know when my mouse pointer is on it? It's a kind of very faint grey, so I don't know how clear it is on the screen. But can you see that's -3 as an x coordinate? And if I move over to this one, can you now see it's +3? Right, so you can't see this, but I'm writing down right now the integral from -3 to 3, because we're going to find the area between the two curves. Now, the next thing I need to know is f of x take away g of x. One of these curves is the high one, right? And the other one is the low one. So if you imagine a little vertical rectangle here, do you see that the red one, 12 minus x squared, that's like my f of x, isn't it? That's my first function. And then don't I take away the one below it, the blue one? So I'm going to take away the x squared minus 6 dx. So now I have to jump back, if I can figure out what buttons to press, and show you what I've got. There's my guys, right? Remember where I got the -3 to 3 from? We'd a picture like that. That was 3, right? And that was -3, right? Boom, boom, boom. There's my f of x. That was the one on the top. And there's the g, the guy in the bottom. Now, if you can set this up correctly, in my opinion, you've broken the back of the question. Most of what's about to happen now is just pretty basic algebra and power rules and all the stuff that you need to do. So the first thing I'm going to do is make a mistake. This guy, take away this guy, and I wrote that down. What's my mistake?
6 is supposed to be positive.
Correct. That's why I put brackets around things, because if I don't put brackets around things, aren't I very naturally going to write that down the way I had it a minute ago and make a mistake? It's just a way of emphasizing, remember to take everybody. Now, the next step I think is pretty straightforward, pardon me. Shouldn't you collect any like terms and tidy it up as best you can? Because that's probably going to make your life easier in the long run, right? So you agree that that's it. Now, as far as integrals go, isn't that pretty much a power rule and nothing clever? Right, so let's do that. 18 gets you 18x. Add 1 to the power, divide by the new power. Evaluate it at -3 up to +3.
Just a question.
Yes.
So isn't minus x squared minus x squared minus 2x squared?
Did you all catch that deliberate mistake that Jessica found? Does anyone believe that that was a deliberate mistake? You shouldn't. The first one was a deliberate mistake. The second one was a normal, undeliberate mistake. Right, but well caught. So it's going to be what? 18 times 3, take away 2/3 of 3 cubed. Subtract 18 times -3, take away 2/3 -3 cubed. What's that? 54. 18. -54. That's negative 2 negatives plus 18. What do you get? 54, take away 18, add the 54, take away 18. Just about made it. The area between those two curves is 108. Are you comfortable about the process that I used there? Go to Desmos first, draw a darn picture, because it's going to tell you a start and a finish. Sometimes the question tell you the start and finish, which is nice. You don't need to worry about that. But I'd still draw the picture to get a feel for it. Set up your integral from start to finish. Figure out who's the high one, f of x. Take away which one's the lower down one, g of x. Tidy it up. Integrate using the typical rules that you would use. Plug in your numbers, answer. Right, it's got a nice flow to it, right? From start to finish, it's got a flow to it. It doesn't jump around too much. Are we good with the first one? Because I'm going to do another one in a moment. Okay. Now, again, I'm jumping around because that seems to be what I'm doing today. And I'm going to show you what that question looked like on the homework, just so we can get a feel for how the homework works. Right, maybe make this, can I make this bigger? Okay, I think I can make it there. That's funny. It says sketch the region, and it gives you 4 pictures. Now, although my picture is gone now, the one that looked closest to it would have been that one if you'd made the window go. I know it's a bit hard to remember, but can you remember the 3 to negative 3 and above and below? I think it was that one, wasn't it? Forgotten now. Oh, I take it back. It was above and below. So, the above and below one, it would be one of these two. I guess we'd have to look at the picture a little bit differently. Was more above than below. More above than below. Okay. So it actually ended up being that one. Now you find the area, all you do is you type in my case, 108. Now they want exact values. So 4.5, no good. Has to be 9/2, right? E squared, good. Not 17.1234 or whatever E squared is. Right. So keep away from decimals, only fractions, square roots, and it's okay for the answer to be, 5e take away 2. It's okay to have weird things like that because that's exact. Let's see. Let me look at a different question. Let's do a version of that one then. Now, the next question that we're going to deal with is, again, area between the curves. But in this case, you're given a picture. And the one I've got looks something like this. And the picture has that guy there. You're being asked to find this area. Looks like a horn to me. This curve here is called y equals x e to the x squared. And this curve here is y equals e to the x. So in this particular case, I really don't need Desmos because that's what Desmos would have done, right? It would have shown me this. But I do need to set up the area of the integral. Now, this number here is definitely 0. I can kind of tell that, right? It's the y-axis. But don't I also need to know this value of x here? And the information is on that picture. What value of x is here, where that arrow is? Right, 1, e. X is 1, y is e. Top guy, take away bottom guy. Which of those two functions goes first? And then which one do I subtract second?
E to the x goes first.
Right, that's us set up the integral that will give me the area between these two curves. So far, so good? Now, this particular integral I am going to do in a very specific way. I'm going to split it up into two separate integrals. Now, normally I wouldn't do that because normally couldn't you integrate all of this as a power rule and keep everybody together? But can you see why I've decided to break this piece off? Because isn't this going to have to use a technique that we used last week? Right. Let's get this guy out of the way. E to the x evaluated at 0 and 1. That gives me e to the 1, take away e to the 0. E to the 1 is e. And what number, and it's a number, is e to the 0?
One.
E to the power of 0. Right, now, takeaway. I guess I'll have to put brackets since I've put a takeaway here, but that's fine. What technique will I use to find x e to the x squared? What method will I use to find this integral?
Use substitution.
Agreed. And who is the u sub that's going to work for this question?
X squared.
Right, aren't we using the rule ugly, what's the word I'm looking for? Ugly power of v is the right, is the right guy to use. So we now have du by dx equals 2x. The crossover gets me that. And the isolating of the dx gets me that. So I now have the integral of x e to the u times 1 over 2x du. That will become, because the x's cancel, that fella. Integrating him is actually quite easy. But return him to the x squareds. And then I can do the limits. So do you notice the limit from 0 to 1 disappears until you get back to here? Because the problem is that if you don't do that, some people do this, they get to there and they make u0 and u1 and they come up with an answer that's not the right one. It has to be in terms of the x. Right. So that's going to get me 1/2 e to the 1 squared, which is 1. Take away 1/2 e to the 0 squared, which is 0. That's going to be take away 1/2 minus 1/2. So I'm going to have e take away 1, take away 1/2 e. Take away a takeaway is add. And it looks like I'm going to have 1/2 e minus 1/2. And that's the answer to the area between these two curves. Are we good? Any questions? Are we good? Okay, move on. This is another question where the diagram has been already given, so you don't need to worry about Desmos. You got this guy? You got this guy? You got this guy, a vertical line, and this vertical line tells you this. The area that you want's this bit here, and this coordinate here is 1, 1. So we have everything that we need in this picture to set up the area between two curves. It starts at x equals 1 and it finishes at 27. You see, that's basically the 27 that I'm using. So it's going to be 1 to 27. Would you agree that the high one, the one that's tallest, biggest, whatever you want to call it, is the cube root of x? And the 1 over x is the lower one. So that's my f of x take away g of x guy. Are you comfortable about the way I set that question up? Does it seem how I got the start and finish limits of integration? Who goes high, who goes low? Now, from this point onwards, it's just practice at integrating things. I'm not going to take this one the whole way because we have a time issue. I want to get as much as we can. Do you think I'm going to leave the cube root as a cube root if I'm going to integrate it? Okay, Victoria, go for it. What fractional power?
To the 1/3.
Agreed. What do you think I might or might not do with the -1/x? Do you think I'll leave it alone? Or do you think I might call it x to the -1? Because this is a sneaky one.
Leave it alone.
Agreed, because isn't this the only time you don't make it a power? Isn't this guy a special case? So add 1 to the power, divide by the new power. And this fella here, the special case, what is he? What's his antiderivative?
Natural log.
Isn't that one of the guys in that big table you have to memorize? You know, like I have to know what the cosine of x is. I have to know what 1/x is, those kind of guys. And that's going to be evaluated at x equals 1 to x equals 27. I wouldn't quite do that yet. I would write it like that. In fact, I might not even write it like that. I would do that instead, because that's a little bit easier to calculate with big numbers. And the reason I want to do that is to make sure that I get exact values. Now, if the number happens to be a perfect whole number, which actually in this case it is, it probably wouldn't matter. You know, your calculator will tell you it's 16 and that's fine, whatever it is. But it's, you know, those ones where it isn't perfect, it's like 7√3, you know, those kind of cases. If you don't write it in one of these forms, you'll never be able to figure that out. So I'll just do my, what I call ... which means you've just finished it off yourself. Are we okay? Set up? Right, next one I'm going to do is a trig question. So this is a bit like question 5. It's going to be y equals 3 cosine x. And it's going to be y equals 8x squared take away 2. And I forgot, it says pi x, not x, but the cosine of pi x. And this is one of these questions where you need Desmos, because it gives you 4 pictures and one of them's right, but you won't know it until you've looked at Desmos. And then you have to get the area. So here I go, closing windows all over the place and getting totally confused, but eventually I'll figure out what the heck I'm doing. Right, I'm on Desmos. Now you need to see Desmos. See if I can get that bit done. Hey, I'm getting better at switching all these windows. I did that pretty smoothly. Okay, kill these guys off. New guy in town. And the first one is going to be 3 cosine pi x. No, it's not going to take that. I need to find pi, don't I? So, okay. Where's pi hiding? There it is. Okay, did you see how I had to get pi in the keyboard? In some software packages I've used, capital P, little I is recognized as pi, but not this time. So that's my first function.
Yeah, I think it's recognized on the actual Desmos website. Maybe it just doesn't work in your little integrated thing here.
Window. Yeah.
Yeah.
Okay, that's not so bad then. Next cell is just going to be 8x squared. I tend to just use it this way because it's quicker than the keyboard, but that's just me. Right, now, it's pretty obvious that this picture is not very helpful. So I'm going to zoom in and zoom in till I think I'm happy. I'm about happy here, right? The area between the two curves is this piece here. You see it's made up of a green bit and a blue bit. It looks like a big egg to me. Do you see that shape? And that guy there, do you notice that its value is, I'm going to draw a little baby picture of this so when I return to my thing, you can still see what I'm talking about. Right, we have a guy that goes like this, and we have another guy that goes like that. And the bottom guy is the 8x squared minus 2 because he's blue. And the top guy, which is the green one, is the 3 cosine pi x. And that point there is negative a half. And at the other side, it is positive a half. But I'll move my mouse pointer just to make sure. Yeah, do you see it? So now what I'm going to do, fingers crossed and all that good stuff, is I'm going to return to this picture. And I believe it's that one, but you can double check there. And I got a nod, so that's a good sign. So now I'm going to return to the whiteboard and we'll see what the math looks like. So, right, that was basically what Desmos told me, right? And we want all of this. So the area between the two curves is from negative 1/2 to positive 1/2. The cosine was the top guy. And the bottom guy was 8x squared take away 2 dx. Now I did this earlier today. I'm going to do it again. I think in this question, it would just be less confusing if you separate them out. Would you agree this piece on the right hand side is just a basic power rule? So I'll get that one down right first. I might actually do this as my working. I might just go over here on a piece of whatever, scratch paper. Power rule. Add 1 to the power, divide by new power. The negative 2 gets me that. From negative 1/2 to positive 1/2. That gets me 8/3, 1/2 cubed. Take away 2 times 1/2. Subtract 8/3, negative 1/2 cubed. Take away 2 lots of negative 1/2. 1/2 cubes an 8th, that times an 8th, I believe you get 1/3. That times that, you get negative 1. Subtract, you get negative 1/3, and you get plus 1. So 1/3 take away 1, take away a negative, take away a 1. That's okay. For a minute I paused there and I'm saying, oh, but that's negative and I know the answer should be positive. And then I thought, wait a minute, that's the guy that's going to go here. And so it's okay, can you see, because you're going to subtract that guy. So it's going to be 2. This is trickier. This is a U sub. I need a U sub to do. Right? I need to do a U sub on this. Who is the U sub? There's not an awful lot to choose from, is there?
Pi over x or pi x.
Agreed. So when you differentiate with respect to x, you just get pi. When you do the crossover, and then you isolate by dividing both sides by pi. So you isolate the dx. So this becomes the integral of 3 lots of the cosine of u times 1 over pi du, which becomes 3 over pi cosine of u. And that's easy to integrate. You get that. And then you return back to the x's and evaluate them at -1/2 and at +1/2. So what's that going to get me? 3 upon pi, the sine of 1/2 pi. Take away 3 upon pi, the sine of -1/2 pi. 1/2 pi is 1, so that guy there gets me 3 over pi times 1. And does anybody know what the sine of -1/2 pi is? That's a bit sneaky. Do you know what it is? You could probably plug it into your calculator and find out that it's -1. You trust me on that? It's -1. So this guy gets you 2 negatives, make a plus. Oh, 6 over pi.
Can you scoot up the paper a little bit? Thank you.
So 6 over pi, take away -2, 6 over pi plus 2, the area between 2 curves. Do you think, we're closing off now, do you think you're getting a feel for this process of how to get the area between a curve? If you don't, if you're given a picture, you don't need to do Desmos. If you're not given a picture, you really do need Desmos, right? Because it has the numbers that you need, right? And the picture helps who's top, who's bottom, and all the other cool things. And then it's just a matter of putting all the algebra skills and the integration skills that you've used, you know, like x e to the x squared was a u sub, 4x cubed was a power rule, cube root of x was make it a fractional power, and then it's a power rule. And what else did we do? 1 over x was a log, you know, things like that. You integrate. And then you plug in the start and finish, and you'll get a number, and that number is the area between the 2 curves. So you might think, what's going to happen tomorrow? We are going to find the area between 2 curves, but this way. We are going to be finding area between 2 curves, not above and below, which is what we've done today, but left and right. You could probably guess what the formula is going to be, but I'll tell you what it is. The integral from c to d of f of y, take away g of y, dy. So it's going to be really very similar. In fact, if I did that, wouldn't it be what we did today? So you're going to be dealing with x equals functions of y, right? Instead of y as a function of x. Now I've got a guy here called f of y and g of y. When we did it today, wasn't f on the top and g on the bottom, right? when you do it with the y's, which is this way, which one of these two do you think is going to be the f?
The right one?
Correct. And you might say, well, how come that's the f? Doesn't that one have a bigger x value and therefore is the big guy? And doesn't this have a smaller x coordinate? And so it's the small guy. When you did it this way, wasn't this the top because it had the biggest y value? And this was the bottom because it had a smaller y value. Bigger x, smaller x. Bigger y, smaller y. It does have a logic to it, right? Right before left. What do you think would happen if I accidentally did the calculation with them the wrong way around? Let's suppose the right answer was 10. What would happen if I did it the wrong way around? What do you think the answer might be?
Something like -10.
Yeah, exactly. It will be the right number, but the wrong amount. It'll be a negative the thing. So when you're doing your homework question, especially if it's a really long question, and you end up with -10 at the end, and then you say, oh, flipping bananas, I should have switched the F and G. I can see it now. You know, you don't need to do the whole question. Can't you just call it 10, stick it in the box and move on and try next time not to do that? Right. So it's a little trick.